Hi, I'm Andrew Armstrong and welcome to the Back Office Show. If you're like me, you like the idea of robots or animatronics or things that move other things using digital commands on a computer. So if you have a Boobie board and you have a PicKit 3 programmer, although this is a clone, I've got both, these work pretty well, and servo motors, you can do a bit of magic and get this to do some wonderful things. So the first step, oh by the way, just before I continue, I do sell these on my website, and I probably, if you ask me before you buy them, if they're not there, I'm going to put a drop down to have these pre-programmed and preset to do this project at the end. But let's continue, show you what you can do if you've already got one. So what you'll need to do is reconfigure your Boobie board to run using the 20 megahertz, and that's right there, oscillator. This is the crystal oscillator right there, and you can see next to there's a couple of little jumpers left and right, and I'll show you how to set those. The only downside, by the way, just remember, if you look closely, you'll see it says RJ5 and RJ4, and there's a P and an O. P means port, O means oscillator, and it's a three-way jumper. You'll see it if I put this one next to it. You can see this is a standard configuration. It's actually set the other way using those two ports as general I/O that come out here on the bottom. So it does mean you lose a couple of channels, but that's fine. So I've got here a sort of hacked Boobie board. I always use them for other things, but it doesn't matter. I'm going to show you how to move those jumpers. So what you'll need is your soldering iron, and if you don't have a soldering iron, really you ought to be getting one, because you shouldn't be really trying to do too much with your Boobie board without one. So I'm just going to move those jumpers. So heat your soldering iron, and you'll see there's a blob already on there, because I personally hand blob these when they go out. And what you can do, if you just run your soldering iron back and forth a bit, you'll be able to move the blob onto the other side. You'll just be able to convince it. So if I do the same here, watch, moving the blob, moving the blob, moving the blob, and then eventually it'll pop here on the other side. And if it doesn't, by the way, if it's, you know, you can always add a bit of extra solder. So I've got some solder here. You can just add a bit. You just want to make sure though it's not on both, that's all. You can get rid of it. There's a gap, there's a gap. Now, if you do have it on both, you can ask, what happens then? Is it disaster? Well, not really. If you have it on both, basically it'll link the output of the crystal oscillator to these pins. Now, I haven't tested this. It may still work. However, it's more likely it won't. But if you've got an appropriate DSO with maybe 100 times probe, you might be able to actually measure the crystal oscillator here. And if you do, you'll see it's running at 20 megahertz. So there's your microcontroller, there's your crystal oscillator. And before I zoom out, and we'll have a look at the other parts, so just to show you, you've got your standard serial lines here that are also duplexed into this FTDI232 chip that's USB. Why is that important to know? Well, it's the same sort of thing really. If you want to, you can see these solder jumpers here, and I'm going to show you again side by side with an unadulterated one. You can actually cut, there's a little trace between these, and if you cut those, you'll disconnect this chip out of the circuit, which means if you're using an Arduino or something with a serial line, you can actually hook that directly there at 57600 board or whatever this project will run at, and you can run this directly from another microcontroller, so you don't always need to use the USB side. So that's what I've done here. In fact, I've not only cut those, I've actually hooked these up to leads because I wanted an external serial to use the USB serial chip. But I digest. Let's move those away. Now, what else you'll need for this project? It's not much actually. You'll just need some of these servos, and these are micro servos. You can buy them on eBay, and it's a bag of 10 for a tenner or something like that. They're not particularly expensive, and they come in different ratings. So this whole project will be able to run these up to almost as big as you like, really. You can see here micro servo 9G, so that's a 9-gram servo, so it puts out 9 grams worth of torques, and they come with these hats. So the hats allow you to connect the actuators to other things, like real world things. So you've seen them on sort of model helicopters and aeroplanes, and they just sort of pop on the top like that, and there's a little screw to keep them put, so they will not move once you've set these up. And they use these in the movie industry and stuff. You've seen them to make animatronics, things like that. And just to sort of show you end to end, I'm going to run it all the way to the left, and I'm going to reset the hat so it's just purely horizontal. And then we go like twisting that round. So you can see it's about 180. Yeah, they move about 180 degrees, so that gives you, you know, a fair amount to play with, to be honest. You can imagine generally when you're using these in aeroplanes, you've got levers, so you've got maybe a bit of wire on here and it's pushing something, pulling something, a bit of wire actuating. Very cool, very useful. And there's one more thing you can do, and I'm just going to jump up. I'm going to reach up because I hadn't thought about this. But if you're running a lot of these, you can run quite a number of these servos. You can basically run one or two. In fact, to be honest, I'm talking rubbish really. You could run many of these size servos directly off, say, USB power, battery power. But if you want to boost it on a Boobie board, if you get one of these jacks, and again, I probably throw them in the box if you order one of these online. What you can do, you'll see there's a jumper here, and I'll show you that. You can see there's a power jumper, and that says VUSBJ, so that means the voltage from the USB, and it's all to do with how the USB powers the circuit, basically, and whether or not it goes through this regulator. But what the main thing you need to know is if you solder one of these on, like so, you can put in a voltage, and I would recommend something around 5 volts because then this onboard regulator doesn't have to work so hard. So you can connect that. This will regulate down and give you a 5 volt output. Alternatively, if you put a 5 volts in here, pure 5 volts, it will be also present on this V-in line, and then that will allow you, of course, to connect your servos straight there, because your servos have 3 wires on them. And the colours are thus. The brown wire, in this particular case, is negative, the red wire is positive, and the orange wire is signal. So I'll show you how we set this up. So we've got a bit of breadboard here. You know I don't normally breadboard, I like to solder straight to me Boobie board, but I know you like breadboard, so I've done this for you guys. I'm just going to hold this up. So you can see I've got the Boobie board attached to the edge of the PCB with the lines running this direction, and it's really kind of simple. You've got here USB, so that's communications to the Boobie board, so I can communicate to the PC and control it. I've got a header I've soldered onto the programming port because I've got it hooked up for doing the software dev, so you may or may not need this if you don't plan on altering my firmware. And then underneath there I've got these servo motors, and they're all connected. In fact, I've got 6 of them connected. I think I might be able to squeeze on another maybe 1 or 2 of them, but definitely there's enough ports for 6, and at least, let me have a look at the board here, and I've still got RC3, which is an output on there, so I've definitely got at least 1 output and maybe another analog channel there to use. So you could probably control these from some operations on there, which is great, or even throw maybe another 1 or maybe even 2 servos. Anyway, I digest. And how they're hooked up, really easily, each one has got 3 wires, the red being the power, and that's going to go there to the 5 volt line on your Boobie board. So you can see I've got these, well, they're going to orange. The red wire actually is going to orange on my little jumper cables. And then I've got the yellow wire that's on ground, and then the blue wires are actually going on each port, each I/O port. So I've got 6 I/O ports in a row, and they are running from pins 10 to pins 15 on the Boobie board. Is that 6 really? 10 to 15? 1, 2, 3, 4, 5, 6. Yes, it is. It's too early in the morning. But pins 10 to 15, they're the blue wires here. They're actually attaching to the orange wires on the servo. Yeah, I could have done a better job of that, moving the blue and the orange around, but don't worry about that, because servo wires kind of come in different colours as well. Just check the pinouts of your servos. So we have 6 servos, and they're connected all up, and that's it. So that's the essential stuff there. And if we move up to the desktop PC, I'll just show you how my my sort of desktop's arranged here. So I've got the PCW C code IDE, and you can use your own compiler and stuff. It's not, whatever you've got for your microchip, and I'll provide you the source code for this, and you'll be able to port this to anything. But I'm just gonna close that window and have a look here. So just to show you, here it is, arcade servo I'm calling it. I don't know why I put arcade in there, it's probably just cut and paste from a different project, but you can see here, requires the XT oscillator jumpers being set on the Boobie basics. Again, just set them up, and then it will set it to 20 megahertz. And here I'm saying the baud rate is 57600. So we'll be able to play with that. Maybe we can get different performances if we check the baud rate. So that's the code. You can go through the code at leisure, and there's a few commands. I'm going to show you what they do, and I'm going to post that all up onto GitHub. Testing. I've also got next to that here on my desktop the actual PitKick 3 programmer software, and it's really easy. All I have to do when I'm running this, by the way, I just click compile, which is here, compile, and that will compile it up, and you can see there on the screen we've got, oh, let me have it do it again so you can see, you've got 24% RAM use and 24% ROM use, so that means there's plenty of space on your Boobie board for your own code. And then I just click write, and what write does, it actually reads the hex file and writes that to the device that I've sort of got in that little rig, you know, sort of hard coded down that white wire at the top. So I just hit load the firmware up. You could hear, you might just heard all the servos twitch then. I'm hitting write, and that's it, writing program memory, all programmed up. Lovely jubbly. And then I've got this other bit of code here, this other sort of program, and this is and in this window I've got real term, and there's a really simple protocol I've implemented right now. So if you push the keys Q to P, it'll run the servos through some default values. So it's the servos have a value typically on these servos, I've noticed, of a value of 1 to 20. I'll explain what 1 to 20 is another time, don't worry about that too much. But if I push Q on the keyboard, you can see on the serial program nothing actually happens, but you might hear in the background stuff happening. So there's no output. The serial never actually goes from the Boobie board to the screen, apart from in one certain circumstance, but I'll show you that in a moment. So I'm pushing Q, they all move to one end, and I'm pushing P, they all move to the other. And if I just go through the keyboard, Q, W, E, R, T, Y, U, I, O, P. So I've got a few settings there that I've sort of hard coded. And then if I push A on the keyboard, I've got a kind of a random mode where they just sort of go through various ranges of motion. Seemingly random. And that's about it. There is another way of controlling them. So just to show you, we've got these, this is going to be unit 11, 10, 9, 8, 7, 6. So they're going to go in that order. So from 6 to 11, the way I've attached them to those pins. So if I go up here and I just type in on the keyboard, I'm going to type 0, 6, say 2, 0. That'll put this number 6 all the way in one direction. And if I type in 0, 6, 0, 0, and that'll put 6 the other way, and I'll just show you that again. And every time you type in one of those commands, you get an exclamation mark to tell you that it's executed. And that's it. So if I want to move 11, I just type in 1120, 1119, 1118, 111. Where did I get 7, 1116, and the servo is just going tick 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 through the settings. And now if you're doing a communication between a PC and the device though, and you want to sort of do a sort of synchronized thing, just send all zeros until you see the exclamation mark, and then you know it's ready. Basically, it's looking for 4 characters. That's the basic interface, looks for 4 characters. So if you don't know where you are and you want to sort of calibrate your synchronization between the two devices, just 4 zeros. As soon as you see the exclamation mark, you're good to go with your comms. And you can just write a stream, continuously write a stream for controlling all these. And you can do that through a script. But if you're a bit lazy like me, just push A on the keyboard and you get them to do a little jolly dance. Groovy. So you can take up your notepad, and in Notepad you can actually create scripts. So I'm just going to use an example here. Because this serial software actually allows you to send text files, I can actually create scripts of predefined behaviours for these servos. So I'm just loading up Notepad in Windows, and I'm going to set channels 6, 7 and 8, and so those servos that are attached to 6, 7, 8 to 0, so that'll move them to one end of their travel. And 9, 10 and 11, I'm going to set them to 20, so they'll move to their other end of the travel. So I can save that file and then click over into my terminal software, find the file, and you can see here I've added a slight delay. That's because it's depending on how you're set up, if you don't have enough delay it might send them too quickly, but we'll tune that. We'll leave that at 11 for now, and then I'm going to send those to the servo. So 3, 2, 1, click send. And you'll see that these servos on the other side here have actually moved. I expected this one to be pointing the other way, but looking at my code, I've actually made a blunder. But still, shows you the point. You can run the script, and now they've done that. So you're probably asking yourself, how's that actually useful? So you can send a script and it'll just do something. Great, so they'll all move to a particular setting. Well, how it's useful is because using a programming language or scripting language, whatever you've got, you can actually read things from your PC and have these react. So, for example, if you're on Twitter, you can have one little servo raise a little flag to tell you you've got a tweet waiting. If you've got emails, you can have little things showing you different status of emails, maybe a graph to show you how much your server's using. If you've got 6 of these, you could create a whole gauge cluster. You could have a dashboard in your car with all the little needles moving around, reacting to things it's reading, say, from a Raspberry Pi. So the possibilities are endless. And I'd love to hear about some of your ideas down below. Ooh. Just thought of another one. Animatronics. At 3D printers, you could probably make robot heads and all sorts of stuff jiggle around. You can chain many of these together. You don't just need to use one Boobie Basics. You could have 10 of them, right? So 10 with 6 servos each. That's 60 servos. There'll be loads of things you could do with that. It'd be insane. But yeah, please comment down below. Give me some of your ideas. Ping me if I haven't posted this online, but I should be putting them up at some point on my website, so you could buy one of these pre-coded with this firmware, so at least you don't need to program anything and you can just start running them in your projects. So, as ever, thank you for watching.